This is AP Calculus, section 7.1, page 1. This section is really a lot of review in here. We have discussed all of this material throughout the year, just in a different context. Some of the important concepts that you should remember are that velocity is the derivative of distance. And then that means that the antiderivative of velocity is the net distance traveled or displacement. If you are in physics, this should sound very familiar to you. Also, that integral of the absolute value of velocity is the total distance traveled. You can also find this by finding the area between the velocity graph and the x-axis, taking all areas as positive. That'll make sense a little bit if you're a little fuzzy when we come down here and look at this example. Also, acceleration is the derivative of velocity, which means that the antiderivative of acceleration is velocity. And then, jumping down here, the position at any time t of a particle is its s of t, or s of 0, which is its initial position, plus the integral from 0 to t of velocity dt. And this integral from 0 to t of velocity is displacement. So its final position, if you will, is its location where it started, then plus how much it moved, or its displacement. And finally, this last bit here, the integral of any rate. So of, say, shoveling. So if you're shoveling snow at a rate of 6 cubic feet per minute. So if you shovel snow over a time period, say from 9 a.m. to 12 p.m., so 3 hours, the total amount of snow that you would have shoveled, that's 6 cubic feet per minute times the time period, 3 hours. So the total amount of snow shoveled would have been 18 cubic feet. All right, taking a look at this example, we're showing a graph of the velocity of a particle moving along a line. So this particle is moving along a horizontal line, back and forth, back and forth, back and forth. And we are graphing its velocity at any particular time. In this section right here, from time 0 up to some time r, the particle is moving to the right because the velocity is positive. Also, this section here as well. Velocity positive, so the particle is moving to the right. This piece down here, between time r and time b, velocity is negative, so the particle is moving left. At this time r and this time b, that particle is changing direction. Velocity is 0, and velocity is changing from positive to negative or negative to positive. So we have a change in direction. Okay, let's take a look at this endpoint over here, S, and just for our purposes at this point, what if this came down and turned back up? Then there would be no change in direction, even though that velocity did hit 0. But there is no change in direction. So this is like coming to a stop sign, making a full and complete stop, and then continuing in a forward direction. If we look at this picture then and talk about the net distance traveled, that would just be the integral from time 0 all the way to the end. And we did add on that piece, so we are going to stop this at s. So the integral from time 0 to time s of velocity dt. That's the net distance or displacement. The total distance traveled, there are two ways to express this. It could be the integral from 0 to s of the absolute value of v of t dt. Oops, absolute value should be here. Or we can separate that and look at the difference between positive and negative velocities. So we could integrate from 0 to r of v of dt, which is positive, then subtract off the integral from r to b of v of t dt, and that integral is negative, or the value of that integral is negative, so when we subtract it, we actually end up adding this value, plus then the integral from b to s of v of t dt. If you have a calculator to evaluate a problem, you'll probably go this route. Just type in and do absolute value. If you don't have a calculator, then you are going to have to separate this at those time values. If we look at this last one then, if s of 0 is 17, then what is s of s? And this notation is a little bit awkward here. S, this little s, is position, and this big S up here, that is a time. So by this notation, I'm asking you what's the location of the particle at time uppercase S. And to do that, we have to take where the particle starts, and it started at position 17, and then we're going to add on how much it moved, which is its displacement or net distance. So where it started plus its net change in position, that will give you the final position. Again, most of this from section 7.1 is review, so you should be good to go. Go ahead and get started on the homework. Thank you.